let's take a look at these integration by parts and trig integrals. Okay, these are fairly typical integrals, the kind you're going to see in the test. First one is the integral from 1 to e x natural log x. The whole point of integration by parts is to take the integral that's given, one that cannot be done immediately, and change it into an integral that can be done. Okay? You have to identify a u part and a dv part. Now, if you let dv equal the natural log x dx, you'd have to integrate natural log. That is not an integral that we have. As a matter of fact, the integral of natural log x dx is an integration by parts problem. So let's not do that. Let's let u equal the natural log of x. The dv will be the x dx. Okay? Du is 1 over x dx. V, the integral here, is x squared over 2. Okay? We can now rewrite this integral. uv. Okay, uv. Minus the integral of v du. 1 over x, x squared. One of the x's cancel, we get x over 2. Okay? We have x squared over 2, natural log x, minus. This is x squared over 2 when you integrate it. That's x squared over 4. From 1 to e. Substitute in e, we get e squared natural log e over 2 minus e squared over 4 minus. Substitute in 1, we get 1/2 natural log of 1. Natural log of 1 is 0. Forget that, that's gone. Plus, because it'd be minus minus, so plus 1/4. What's the natural log of e? 1. Wait a second. Who was up here? So you got all those e's after you made the substitution in there. Oh, so you were fine. I couldn't see how you were going from...
Like I said, my handwriting's pretty bad.
It wasn't your handwriting, Nick. It was me. It was totally me. You get e squared over 2, e squared over 4, plus 1/4. I was forgetting this is a definite integral. I gave you limits of integration that you had to substitute in. And that's what gave you from the natural logs here into the e's here. And now you got one more step here too. E squared over 2 minus e squared over 4 is e squared over 4. So you get e squared over 4 plus 1/4. You get e squared plus 1 over 4. Guess me.
Is that x squared over 2?
X squared over 2 right here. Second one is x squared over 4.
Now I got x squared over 2 and x minus for the integral.
Okay, I don't know where you are. The integral right here?
Yeah.
That integral of x is x squared over 2, which makes this a 4, because you already had a 2 there. So now you got a 4. That's where this 4 is coming from. Is that it? Okay. That would be your final answer, yes.
Where'd the e squared divided by 2 go?
These guys combined into one fraction. Multiplied by 2, multiplied by 2. You get 2e squared over 4 minus 1e squared over 4, which is an e squared over 4. Okay? All right, everybody else set on that? Okay. All right, second one, x cosine x. From 0 to pi over 2. And again, we have an integration by parts problem. We have a u part or a v part. And now you really don't have any choice here in the matter here either. You're going to let u equal to x, and the dv is cosine x. The reason is when you take the derivative of this, you get dx. If you had done it the other way around, you'd have to integrate x, and you get x squared over 2, and that integral, the problem would be more complicated, not less. So you have to do it this way. The integral of cosine is sine. So uv minus the integral of v du x sine x minus the integral of sine x, negative cosine x, so that becomes a plus. Pi over 2, you get pi over 2. Sine of pi over 2 is 1, so you get pi over 2. The cosine of pi over 2 is 0. Then you substitute in 0, you'll get a 0 here, and it's minus cosine of 0, which is 1. So you get pi over 2 minus 1. What's that?
Yep, there.
Okay. Okay? How's that look?
Looks easier when you do it.
Yeah. Okay. Number 3, inverse tangent. Inverse tangent is an integration by parts problem. Many of the transcendental functions, inverse tangent is a transcendental function. Natural log, transcendental. Inverse sine, those are transcendental functions. Many of them you have to integrate by parts, okay? Let's do it. See, that transcendental function, that would be an interesting part of the math history course. How those came about, the transcendental functions versus the transcendental numbers versus the algebraic numbers. And there's some unknown questions today, whether some numbers are transcendental or not. Unknown, it's unknown.
Something to work on, right?
Yeah, something for you to work on this weekend. All right.
I'll do it this week.
All right. The integral of inverse tan x, 0 to 1. We're going to have a u part and a dv part. And again here, things are forced. Okay, things are forced. You can't let the dv be inverse tangent because you'd have to integrate inverse tangent. And guess what? That's the very thing we're trying to do. So the dv is dx. The u has to be the inverse tangent. The du, the derivative of inverse tan, 1 over 1 plus x squared, dx. V is x. Okay? So we get uv, x inverse tangent x, minus the integral of v du. Okay? Pretty simple integral, 1 over u du form. U is 1 plus x squared. The du is 2x dx. We have an x. Let's multiply by 2 and by 1/2. That gives us x inverse tangent x minus 1/2. It's 1 over u du, natural log, 1 plus x squared, from 0 to 1.
Where'd that 2 and 1/2 come?
Well, because if I let u equal 1 plus x squared, the du is 2x dx. I have an x, but I need 2 of them. So I have to multiply by 2 and by 1/2. And that's where this 1/2 is coming from right here. Now, let's substitute in 1. You get 1 inverse tangent 1. The inverse tangent of 1 is the angle whose tangent is 1. That's going to be pi over 4 minus 1/2 natural log of 2. Substitute in 0, you get 0. Substitute in 0 here, you get natural log of 1, which is 0. This is your answer. Okay. Bless you. Bless you. Yes, Nick.
You got pi minus ln 4 over 4.
4 over 4. If you multiply that by 2 and that by 2, wow, that works.
Is that good or?
Well, that works. I got to tell you, I would probably have this answer. You'd have to recognize that your answer is equivalent to this, which it is, which is pretty cool. And then a multiple choice, you just have to recognize that the two are the same. It's one of those things, though, if you got it wrong, I'd at least give you half credit. I may even give you full credit for something like that.
Okay.
All right. All right, let's keep on going. Let's do number 4. the integral of cosine squared. To do the integral of cosine squared, we're going to use a half angle substitution. That's 1/2 the integral of 1 minus plus cosine 2x from 0 to pi over 2 dx. That's the half angle substitution for cosine squared. Well, let's integrate it. Integral of 1 dx is x. Now, you got to be a little bit careful here. This is a cosine u form. U is 2x. The du is 2 dx. You'd have to multiply by 2 and by 1/2. And then you'd have the integral of cosine u, which is sine u. Okay? Be careful of that. Is everybody okay with that? You have to have the 1/2 there because you got to multiply by 2 to get the du part. Oh, guess what? It doesn't even matter if you have the 1/2 there or not because it doesn't even play a role in the answer. That's kind of weird. Anyhow, so you get 1/2 pi over 2. Substitute in pi over 2, you get 2 times pi over 2. The sign of pi is 0. Forget about it. Substitute in 0 to get 0, 0 to get 0. You end up with pi over 4. That's the way it works out. Okay? How you guys doing, all right? Any questions? Anybody? All righty. I'm going to go on in a minute. Are you okay or what? No, not Vitaly. Ed? You're okay? No, it's not Ed. It's, yeah. You were staring at it in such a way that it looked like you didn't know if it made any sense. Not Trent.
I'm good.
All right, you're good. Good, thanks. Okay.
I'll study.
All right, that's good. That's good. All right, here we go. Number 5. The integral of cosine cubed from 0 to pi over 2. Oh, boy, I'm stretching it out here. Okay, here we go. You got cosine to an odd exponent. Here's what you're going to do. Split one of them off. The rest of them, well, I'll write it out. The cosine squared, change the signs. Okay. Multiply it out. You'll have the integral cosine minus cosine sine squared. Okay? Now we can integrate each one. The integral of cosine is sine minus. This is a u to the n form. U is sine, the du is cosine. Okay? U squared du, the integral of u squared is u cubed over 3. And you're going from 0 to pi over 2. That's equal to sine of pi over 2 is 1. Sine of pi over 2, 1. Sine of 0 is 0. Sine of 0 is 0. Answer of 2/3. Okay.
Is that an equal sign?
This is an equal sign here.
No, before.
That's an equal sign.
Okay.
Yep. Bless you. Yeah, we're getting there. Number 6.
Slowly but surely.
Yep. Number 6. The integral 0 to pi over 4. Tan cubed. All right, here's the thing. You have to know the derivative of tangent is secant squared. Given that the derivative of tangent is secant squared, that really tells you what you have to do. What What you have to do is split off a tangent, be left with tangent squared, which you then can convert to a 1 minus secant squared.
It's 4, right?
Excuse me?
Pi over 4.
What's pi over 4? Oh, is it? Oh, it is. I changed it to a 2 for some reason.
No, because all the other ones were 2s, that's why.
Oh, is that what it was? Thanks for defending me, Danny. All right, so multiply it out. You get tangent, secant squared, tan. The integral of tangent is a negative natural log cosine minus. If u is tangent, there's the du, secant squared. If u is tangent, du secant squared, you get the integral of u, du, that's tangent squared over 2. It's u du, because you have the du of secant squared. And you're going from 0 to pi over 4. That's equal to negative natural log cosine of pi over 4 square root of 2 over 2. Okay. Minus tangent of pi over 4 is 1. Minus plus. Cosine of 0 is 1. Natural log of 1 is 0. Forget about it. Tangent of 0 is 0. This is your answer. Okay.
So, I don't get the natural log thing. I don't get it.
This here? The integral of tangent, when we derived this, we said tangent sine over cosine, and we let u equal cosine. The du was a negative sign. We ended up with a negative 1 over u du, which is a natural log. And that's how we got the integral of tangent.
So is the integral of tangent always?
Yeah, yes it is. The integral of tangent is a negative natural log cosine. That's what the integral of tangent is. Okay?
I'm sorry, what chapter was trig substitution? 8 point, do you remember? 3.
That's 3, yeah, 3 sounds about right. Nah, 3 sounds good. 8.1 was a review. 8.2 is it by parts. 8.3 was trig identity, so it's 8.4 then, yeah. Trig substitution. Yes, Nick?
That last answer, could it be anyways 1 minus ln 2 over 2? Or is that,
What are you, some kind of expert in natural logs or something? Right, what do you want to write it as?
1 minus ln 2 over 2, is that,
Square root 2 over 2?
just put a 2 and then over,
Oh, all over 2?
yeah. Does that not work? I don't know.
Wait a minute, I don't know, maybe it works. Jeez.
It's going to be square.
All right, hold on a second. Let me see here. Let's. This can be written as this. This can be written as 2 to the negative 1/2. Right? This can come out front. Holy mackerel, I think you're going to be right.
How did you do that?
How'd you do that? Wait, now I'm going to get 1/2 natural log of 2 minus 1. I got it the other way around. And you know what? I'm going to be right because you're going to get a negative number here.
Yeah.
Natural log of... Wait a minute.
No, you're right.
No, I think you're right. Here, natural log of 2 is 0.69. So you got a positive number. I get the negative. It is a positive number. So I think you are right. Hold on a second. 1 over square root of 2. 2 to the negative 1/2. Bring the negative 1/2 out. You get 1/2 minus that. Wait, so you got this answer? I just got this answer?
Yeah.
Okay. This is 1 over the square root of 2.
Yeah.
This is 2 to the negative 1/2. That comes out. That's 1/2. Natural log 2. Take the 1/2 out. I suspect that the problem is one's the opposite of the other. Well, I think your answer is fine.
All right,
I'm going to go with yours.
all right.
All right. Geez, wow. Nick, what was that, your favorite subject or
This
something?
is my second time taking this. So
Well, still.
figure something out.
That's pretty good. All right, 7 through 9. You ready? Now, this is exactly how it is on the test, okay? Except it's multiple choice of the test. For 7, what is the trig substitution for number 7? What are you going to do? What would the trig substitution be? Let x equal,
Is it a sine one?
yes, it's 5 sine theta. Okay? That would be the trig substitution, 5 sine theta. It's an a squared minus u squared. You let u equal a sine theta, a being 5. Number 8. I don't know what that is.
Tan.
Can I ask this?
No, I'm just going to ask for the substitution.
Tan. All right.
Second one is tangent. X is equal to 5 tangent theta. And number 9,
Yes, that's secant.
secant. Very nice. X squared. Number 9 is the square root of x squared minus 25. And you're going to let x equal 5 secant. Okay. Nice. Okay. What you guys should do is 10, 11, and 12.
I'm gonna wait on that one.
Which one?
Yeah.
You want me to do it? Is that what you're saying?
Yeah. That's what I'm saying. I don't know about that.
Trent, what do you say?
X squared minus 25. Oh, 11? Yeah. Oh, 7x over x minus 1 squared plus x plus 2.
Times x plus 2,
There
yeah.
you go.
Just that full time.
Yeah.
He's gonna write it.
Here they are. 10.
Oh, that's that ABC stuff. Right?
Yeah.
Favorite.
It's my favorite. It's right. I may give the whole test of these. Oh, you like that? Oh, good. Somebody agrees with me.
Better than
So what do you do if there's a 7?
Yeah, just leave it there.
Oh.
We don't pay any attention to it.
Well, at the end, you have to pay some attention to it eventually. There's 3 of these on the test. And you know what? They look just very, very close to what you got right here now.
Probably just not the 7.
Probably not the 7, that's true. Although who knows, it may be the 7. Do, 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 do. Do, 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 do.
Let's look at this sentence here. Needed is a verb, and was is a verb. That's true. Any other verbs in that sentence? What's the subject of needed? Documentation. Ooh. What's the subject of what? Enrollment, was it for that? Document, you know what? The subject of was is actually really the whole thing, the whole first, the whole, what was in your bag? Just the documentation, even for, the whole thing is the subject. All right, is this the simple sentence? No. Past tense is. Not complex. This is a complex sentence. next sentence, into the next sentence, into the next sentence, what's the subject and verb? What's the verb? Is the verb. Is the verb. What's the subject? Yes. Is this a complex sentence? No. It's a simple sentence. Put your hands up. That's a simple sentence.
Dude, we're gonna wake another class.
Excuse me?
They're really awake another class.
I know it. You guys are lucky. That teacher's lucky.
Yeah. If only we were like them.
All right, how you guys doing out there?
It's not that bad.
All right,
Gotta
good.
keep looking back.
Just one subject, one verb, and it's 3 o'clock, right? So,
How do you find the B once you find A? It's
Depends which problem you're doing.
first one.
First one, you got two equations and two, you find B by multiplying through by x plus 2 and let x equal -2.
Oh, I forgot to do that.
Oh, that's what you got to do to find A.
Because I did.
You did it the long way?
Yeah.
Oh.
I did.
Well, you got two equations. Once you find A, you can substitute in and find B. Well, I'm not going to do it that way. I'm going to do it my way.
Yeah, where did it go? I said fast way. So
Yeah, fast way, that's it.
I don't remember where I put it.
You know, this way I'm going to do it.
No, I think I did the fast way. Yeah. I don't know. Yeah, I think I did it the worst way.
I still don't see what the heck is it.
let's look at the sentence here.
Okay, take a minute.
So if I did it the long way, how do I find B?
The long way, once you find A, because you got two equations and two unknowns, substitute your A
Substitute,
value
all right.
and find B.
Okay.
If you're talking to the whole truth, I want everybody to hear you. And if you want to have your side conversation, you close your eyes. It's not just me, it's 15 seconds, all kinds of people. So, this is actually this sentence is complex because it's made up of two sentences with two clauses. That's what we're saying, not answer, right? So what are the two clauses or two sentences that make up this sentence? There's two clauses, there's two sentences that make up this sentence. What are they? Oh, so looking up stuff. Yeah, okay. Very good. Very good. So what are the, I'm not asking you, I'm asking what are they? One of these is,
1 minus 2. Yeah, 1 minus. So, oh,
What?
I've discovered why you are right and I am wrong in that other one. Because when I replaced tangent squared after splitting off a tangent, it's not 1 minus secant squared, it's secant squared minus 1, of course. And that made it negative, and you are totally correct, and then I have the opposite of yours. Okay.
You ordered these.
What's that?
You ordered these ones.
Yes, I am. You guys ready? Let's do it. First one, we have two linear factors. The way to do this problem, think of this, you're going to have an a over x minus 1, a b over x plus 2. We are going to solve for a in the following manner. We're going to multiply both sides by x minus 1. This x minus 1 is gone. We're going to let x equal 1. When you let x equal 1, we will have 7 thirds. on this side. On this side, when I multiply by x minus 1, this x minus 1 is gone. I have a sitting by itself. This b over x plus 2 is getting multiplied by x minus 1, but I'm letting x equal 1. That makes this 0. A is 7/3.
Do you always have to solve for a first?
Yeah, if you put it first, you don't have to. You can do it any way you want, really. It just seems like the natural way to do it. To solve for b, multiply by x plus 2, let x equal negative 2. Negative 2 minus 1 is negative 3. Okay? We get a negative 7/3 here. On the other side, when you multiply this by x plus 2 and let x equal negative 2, you get 0. This is gone. Over here, the x plus 2's cancel. You have b. A is 7/3. B is negative 7/3. If you had this exact question on the test, the sum of the constants is 0. Okay? Number 11. A little bit different 11. We have a repeated linear factor. And that means we're going to have to account for the possibility of an x minus 1 and an x minus 1 squared. We need to have both of these included to generate all the possible combinations.
I put a is x minus 1 squared. Is that
You can do that. That's okay. That's okay. Now, you cannot solve for a. If you multiply by x minus 1, you only get rid of one of these x minus 1s, not both. And then when you turn around and let x equal 1, you have a division by 0. Okay? So you cannot solve for a this fast way. But the thing to do is to solve for b and c. I can solve for b by multiplying through by x minus 1 squared, let x equal 1. 7/3. Wow. What happens over here when you multiply by x minus 1 squared? One of the x minus 1's cancel. You still have an x minus 1, but you let x equal 1, gives you a 0. On the b's, the x minus 1 squares will cancel. On the c's, the x minus 1 squared, you let x equal 1, that gives you a 0. We have b is 7/3. We can solve for c. Multiply through by x plus 2, let x equal negative 2. When x is negative 2 times 7 is negative 14. Okay. Negative 2 minus 1 is negative 3 squared is 9. Ew, boy. Okay.
How'd you do that?
I multiply by x plus
So you just did
2.
the same process, right?
Yeah, and let x equal negative 2. And what happens over here, this will be 0, that will be 0, c will be by itself. Now we have b and c. We've got to solve for a still. What you have to realize that the a would get multiplied by an x minus 1 and an x plus 2. Your LCD here is x minus 1 squared times x plus 2. The b gets multiplied by an x plus 2 only. The c gets multiplied by an x minus 1 squared. I would look at the squares. I have an ax squared. I don't have any bx squares, but I do have a cx squared. I have no x squares over here. That tells me that a plus c is 0. I have no x squares here. And if c is negative 14/9, the a will be 14/9. They must add up to 0. Therefore, the sum of these constants is 7/3. Okay. 13.
What did you say b was again? Sorry.
That's all right. It's okay. B was 7/3.
Same as a.
A was 14/9. You all set on that?
Yeah, I just put a different one for a. So.
Oh yeah, you're
So
in.
I'm still
Yeah, I
in.
know. All right, number 12. 12 we have 5 over x squared plus 1, we have an x plus 1. This is an irreducible quadratic, it cannot be factored. Irreducible quadratic gets a linear factor for its numerator, and this linear term gets a constant. Okay? Well, we can't solve for a and b. We can't solve for a and b because we have no real number that causes x squared plus 1 to be 0. But we can solve for c, and it's worth your while to solve for c. Multiply through by x plus 1, let x equal negative 1. Negative 1 squared is 1, plus 1 is 2. Multiply by x plus 1, let x equal negative 1. We get a 0 here. We have c left by itself.
Wait, why do we just disregard the ax plus b?
Because it gets multiplied by x plus 1, and then you let x equal negative 1, which causes this whole thing to be multiplied by 0.
Okay.
Okay? Now, a and b, let's see what we'd have to do. The LCM, or LCD, either way, of these denominators is their product. This one would have to get multiplied by x plus 1. This one would have to get multiplied by x squared plus 1. Okay? Numerator and denominator here, numerator and denominator here. Okay. I'm going to have an ax squared when I multiply this out, and I'm going to have a cx squared when I multiply this one out. I will not have any bx squares. I have 0x squares over here. A plus c must be 0. C is negative 5 halves. C is 5 halves. A would be a negative 5 halves. Because a plus c is 0, because I have no x squares here. Now, I'm going to look at the constants. I have a b. I have a c. A is not part of the constants. It already has an x attached to it. B plus c must equal 5, the constant here. C is 5 halves. Subtract the 5 halves, you get 5 halves. Okay? 5 minus 5 halves is 5 halves. Okay? It's 2.5. 5 minus 2.5 is 2.5. Okay? Therefore, the sum of the constants is 5 halves. That's kind of cool. That's how you do that one. You'll have 3 partial fractions on the test. They will mimic these 3. They'll be very similar to these 3. Okay? Okay. 13 through 15. What is the correct method of integration? What the heck? For number 13, what method of integration should you use in order to integrate that square root of 9x squared minus 25 dx? You bet it is. That's a trig
Oh, you
substitution.
don't say which one?
That's all you have to do is say what the method of integration would be. My choices would be something like trig substitution, integration by parts, partial fractions,
What's
u to the n
What's
form.
the difference? Integration by parts and parts. You said parts twice.
Yeah, there's integration by parts and a partial fractions. Well, partial fractions is not even a possibility here, okay, because you don't have a fraction thing. You get that square root. So it is a trig substitution. Okay? You would actually let x equal 5/3 secant theta. That would be the substitution that you would need. All right, 14. The integral of inverse tangent. What method of integration is used for that?
Parts.
That's parts. Geez, I think we did it, actually.
You don't put the first question?
Yeah, something like that. I think we did it. 15. What's the method of integration in 15? Partial fractions. Okay, nice. 16 and 17 are L'Hopital's. Let's do them. It's the limit. X goes to 0. E to the x minus 1 over x cubed. Jeez. Okay. Anyhow, what do? You look at the numerator, you look at the denominators. X goes to 0. This is going to 1, minus 1. This is going to 0. This is going to 0. You get 0 over 0, indeterminate form. we use L'Hopital's. Take a derivative of each. Derivative, derivative. Now as x goes to 0, we get e to the x as x goes to 0. That's 1. This is 0. That is not an indeterminate form anymore. As this goes to 1 and this goes to 0, we've got something going to infinity. Okay? We've got this going to infinity. This limit does not exist.
Where did 3x squared go? Like, where'd that come from?
The derivative of x cubed.
So, how do you know if you use the L'Hopital's?
You get 0 over 0 or infinity over infinity. Okay? And 17, limit x goes to infinity, e to the x over e to the x plus x. Well, numerator is going to infinity. Denominator is going to infinity. Use L'Hopital's. Derivative, derivative. Numerator is going to infinity. Denominator is going to infinity. Use L'Hopital's. Derivative, derivative. Whoa, that's equal to 1. The answer is 1.
And that one was easy.
18. Now we've got improper integrals. Let's do them. 0 to 1, 1 over x cubed. What makes this improper is the 0 here. What we'll do is take the limit as a goes to 0 from the right, from a to 1, 1 over x cubed dx. It's the 0 that makes it improper. So, take the limit. A goes to 0. It's x to the negative third. Add 1 and divide. Okay?
Is that -2?
Yes, it is. Because you're integrating x to the negative third.
On top.
Say what? Yes, on top it is too.
Oh.
Yep. Here it is and here it is. I would rewrite this. That's a negative 1 over 2x squared.
Can you just move the paper? Thank you.
You're welcome. And now substitute in 1. Substitute in 1, you're going to get negative 1 over 2, negative 1/2, minus plus 1 over 2a squared. As a goes to 0, what's happening with 1 over 2a squared? Where's that going? Where? You bet it is. Oh, wait, Kessner. Infinity, so this diverges. Okay?
What happened in the step right about the divergent that you wrote? Right about it.
Here?
Yes, I don't get what happened with the 2x squared and all that.
Okay, well, I integrated, oh no, I rewrote it.
You just rewrote it? Oh.
Yeah, that's all I did. I rewrote this. 19. Here we go. Wait, we all set?
Wait,
Yes.
what is that equal to? 1 over 2a squared? When a goes to 0.
When a goes to 0, 1 over 2a squared will go to infinity. As the denominator goes to 0, that fraction, its reciprocal, goes to infinity. 19. We are almost there. Wow.
Close, but yet so far.
Oh, well, we're almost there. We're almost done. We got this. 19. 1 to infinity, 1 over x cubed. What makes it improper is the infinity. We'll take the limit as b goes to infinity, 1 to b, x to the negative third.
Why b, not a?
Because this is a, this is b.
Oh.
Okay? And if this is the b that's causing it to be improper. So, take the limit, b goes to infinity. Add 1, you get x to the negative, you do get just what we just did, okay? It's the same thing. And I'm going to rewrite it again. So you get negative 1 over 2x squared from 1 to b. And now substitute in. You get negative 1 over 2b squared minus minus plus 1/2. Okay, substitute in b, substitute in 1. As b goes to infinity, what happens to this term?
Small.
You get smaller and smaller, it goes to 0, very nice, and the answer is 1/2. This converges to 1/2. Okay? That's how you're going to see it on the test. Converges to 1/2. And number 20, the last one. The integral from 1 to infinity, e to the x dx. Take the limit as b goes to infinity. 1 to b, e to the x. It's the limit, b goes to infinity, of e to the x from 1 to b. That's equal to the limit, b goes to infinity, e to the b minus e. As b goes to infinity, e to the b is going to go to infinity. This diverges.
So what's e to the b going?
Going to infinity. As that exponent increases without bound, e to the b will increase without bound. Woo! There we go. Wow.
That was exciting.
That was exciting.
Wish I could stay longer.
Okay, so test is Monday. Okay? There you go.
Next Monday.
No, this Monday.
Try it if you want to make it next week.
No.